This is a scalable vector graphics SVG file. SVG is a common image format used to store vector graphical data, but vector graphics are used in many other contexts such as fonts. The most notable feature of vector graphics, which makes it well suited for purposes such as fonts and icons, is that a vector image can be scaled arbitrarily without losing quality. This is in contrast to raster images, such as PNG and JPEG, which store their information in the form of discrete pixels and therefore cannot be enlarged past their nominal resolution without loss of quality. SVG images are formatted in Extensible Markup Language, XML, a markup language related to HTML. The two look alike when viewed as text, so my pre-existing basic HTML knowledge was transferable to reading SVGs. Files written in XML are common in web development, as are SVG images, so both are supported by web browsers. An SVG image can be embedded directly into an HTML file with the SVG tag, and a .svg file can also just be opened in a web browser. Messing around in the inspector, deleting parts of files, and manually editing data was how I first became acquainted with the format. I recently released these 3 videos. In their descriptions, I specify that they were made with Inkscape, an open-source SVG editor, Firefox, Notepad++, a text and source code editor, and OBS Studio, a recording and streaming program. Everything seen on screen was hard-coded into an SVG. How did we get here? So, it turns out that the SVG standard natively supports animation. SVG animation is marked up in Synchronized Multimedia Integrated Language, SMILE, a markup language developed by the World Wide Web Consortium, who also develop XML, SVG, and HTML. I don't remember when I first found out about this, but I know that animated SVGs are seen reasonably often in web design. If you've ever seen one of those menu icons that morphs when you click on it or mouse over it, that's likely an SVG with SMILE animation. SMILE animation can be used for extremely basic transformations like translation and scaling. However, I was far more interested in its ability to change the shape of a path object. Being able to stretch and squash a shape is fine, probably useful to me, but it couldn't remain my only tool. I wanted to fluidly morph the shape itself, move individual vertices, or change the curve of an edge. Generally, in an SVG file, an object to be displayed on the canvas will be encoded with the path element. A path can contain a style attribute specifying its fill color, stroke thickness, and others. Fill or stroke can also be partly or completely transparent. However, a path also contains a D attribute, whose value contains the geometric instructions to actually draw the shape. This data is what would be called the path in plain language. For example, here we have a blank canvas in Inkscape. I have the grid turned on, and I'm going to draw a shape. I start at 5, 5, head to the right 5 units, head right 5 and down 5, right 2 and down 5, move left to x equals 5, and then close the shape. And as we see here in the XML viewer, the D value specifies a starting position of 5, 5, moving right 5 units, right 5 and down 5, right 2 and down 5, absolute movement to x equals 5, and the path closes. Now, I sort of begged the question here because I wrote this into my script having already created the sample shape, already knowing how Inkscape would express the resulting D value, and tailored my narration to that. I'm not actually sure why Inkscape chose to specify that that last horizontal movement was to an absolute coordinate of 5. It could have just as easily put a lowercase h for relative movement, and then a value of -12, and that would have encoded exactly the same path. Probably this is some sort of optimization to use as few negative numbers as possible. I just wanted to digress so that I could make it clear that there is no hard and fast rule on where you can use absolute and relative values. If I change the D value to this, then you can see that the result is identical. Now on to animating, and I've switched to Notepad++. There are actually several ways to animate paths, but my method is to add an animate element as a child of the path. The animate will have several attributes. Attribute name tells it the attribute in the parent path to target, and this will be set to D. Dur, for duration, specifies how long the animation will last from beginning to end. I will set this to 1, which is by default interpreted as 1 second. Begin is the time at which the animation begins. I will also set it to 1 so that there is 1 second of dead space upon the file loading. And now we have to specify the value modification. As you can see, the path here is a square. Its D value is M11, H2, L22, L12, Z. What I want to do is move the bottom right corner of this square. I want to animate the bottom right corner of the square moving down and right away from the rest of the shape. There are two distinct ways I can put this into the animate using different attributes. I can either specify an animation by M00H0L11L00Z or 2M11H2L33L12Z. If you're paying attention to the D value I have written here, you may notice that it's got some redundant data in it. I used the line operation L to move from 2,1 to 2,2, when I could have just used the vertical operation V to move to Y value 2. However, I did this for a reason. It is impossible to continuously animate between D values if the commands, the letters, are not the same. The only thing that can change is the numbers. The computer has no trouble continuously changing from 2 to 3, but there is no way for it to continuously change from V to L. For this reason, the redundant data has to stay. It is also possible to use the from attribute to specify a starting value, rather than have the animation start from whatever the path's current D value is. So if I want to have the same animation play out in reverse, but have the same starting shape during the initial second of dead air, I can specify from the stretched value and to the perfectly square value. Additionally, it is possible to have the animation move at a nonlinear pace. The calc mode attribute's default value is linear, including if the attribute is absent, but if you set it to spline, then you can set a pace using another attribute, keysplines. The value of this attribute is formatted as 2 pairs of numbers between 0 and 1. Each pair defines one handle of a Bezier curve with points at 0, 0, and 1, 1. If I set the value to 0, 0.5, 0.51, then the animation rushes at the beginning before slowing down. If I set it to 0.50, 1.5, then the opposite happens. This amount of detail likely seems unnecessary. The lowest level of how the file format works would usually not be of any concern in an explainer video like this. However, I see it as relevant because this is basically how I engage with this format. I've already mentioned Inkscape and shown it on screen, but Inkscape has no support for animation. There are of course dedicated animation softwares out there, but they weren't to my taste, because one of the things I like about SVG is the near-perfect control it affords the user. Everything is completely modular and completely regular. Shapes can be created and adjusted with complete numerical precision, a modification can be made in one place, and then reverse engineered and applied anywhere else any number of times. Inkscape already affords me this hand when creating still images, aided by the fact that, as shown before, it has a built-in XML viewer, but when creating moving images where no graphics editor or animation software exists that supports such precision, what choice do I have other than directly editing the file? This is why Notepad++ got named in the video's descriptions. But before we get to that, let's change topic. Now that I've established the basics of how SVG animation itself works, let's switch to looking at my actual process for making these videos, starting with what was generally my first step. Before doing anything else, I create a project in Audacity. I'm not going to be editing the audio at all. Audacity is primarily useful here because it lets me view the song as a waveform and, more importantly, a spectrogram. And also, very importantly, it lets me place labels on the timeline. You're currently looking at the file for the 6, as it is now, with all of the labels already added. This is not what I initially did because that would be absurd. The only ones I placed at first were the ones that are numbered. These are placed at the beginning of each measure, and at this stage are mostly used for easier navigation. Next, I create a file in MuseScore Studio. Here I will transcribe the entire song on sheet music. Once again, you're looking at the completed score, including some information I didn't utilize when making the video. This score isn't actually meant to be read from while playing. I think I saw Colin say in a Reddit AMA that he doesn't score his own songs in the first place. It's just a way to transcribe the song for my own purposes. I would also like to explain some of the things that I did with this score that factor into the video later on. Firstly, there are 3 staves: voice, which went unused, saxophone, and percussion. All of the percussion heard in the song is created by the saxophone, by its keys and pads and such, so this information is redundant, but it's a redundancy that helps later on. In the saxophone staff, one can see that the note heads are all over the place. This reflects the overblowing being done on the horn. Pretty much all of Colin Stetson's music gets its sonic texture from overblowing. One of the main things the music is doing is examining the complexity that this adds to an otherwise simple foundation. The music sounds the way it does because of overtones, so in order to visualize the songs, I have to take them into account. Once I'm satisfied with the score, I go back to the Audacity project. Now it's time to place a label every single time there's a note. Generally, I would start off by placing one at the beginning of each beat, and then going back through and actually doing every note. Aside from that, there isn't really much of a trick here, aside from do it. I went through, I placed thousands of labels, and then I moved on to the next step. I export all of the labels to a TXT file, and then open the file in a spreadsheet program. I use LibreOffice Calc, but that part doesn't really matter. Now I have the timestamp of every note written in a spreadsheet where I can add all of the other data I'm planning to use. I used 4 columns for the saxophone staff in order to separate out different sections of music, which I had already planned to display differently in the video. In each column, I put a value that indicates the pitch and octave, as well as the note head type. This was a marginally more efficient way to store this information, but I didn't do the next project this way because it would have been far too difficult to write down this way for the entire song. I used 3 more columns for the percussion staff. The value of each cell contained information on the note type as well as the current section. The value starts with either a D or U for down or up, continues with S, D, PU or PD for square, diamond, pentagon up or pentagon down, and some of the cells have a G at the end, which ended up not being taken into account in the final version. The system I used for Among the Self was a lot better. 1 column for pitch in scientific pitch notation, 1 column for the head type, the notation I made up to indicate overtones, and another column, accent bass, which indicated whether I had put an accent mark on the note. This went unused. An additional column, peak ID, determined which of the 5 paths in the SVG would be animated with the data in that row of the spreadsheet. This data was fabricated separately from the score and doesn't directly reflect anything in it. Translating from score to spreadsheet is another area where the only instructions are do it. The pitch data is highly repetitive, so there was a lot of copying and pasting before making modifications to individual measures, but the head type data is highly variable to a point that I just opted to type all of it out by hand. It didn't take as long as it might seem, I just needed to really enter a flow state. Next step, visual design. Each time I make one of these, I go in with some idea of what I want the video to look like. I don't just pick songs that I think are cool. If I did, I would never do anything but make these videos. In order to go to the effort of making a visualizer, I have to have been really struck by a song. If it doesn't look like something in my head, I have nowhere to start. The 6 looks like this. Strobing, harsh images, no continuous movement. This is a song that grabs you by the neck and squeezes you for its entire runtime before abruptly dropping you on your ass. Correspondingly, whenever a pitch was being played, the image displayed on the screen would change to indicate it. The term I used in my notes was discretely switched. This sounds like some technical jargon, but really it's just something I made up to express what I wanted. In the SVG itself, I didn't even use animate elements. I used set elements, a simplified version that basically does the same thing, but can only be used for the equivalent of calc mode discrete animations. They exist purely to be a quicker way of expressing operations that don't need the extra data, so I went with them because they could do everything I wanted this video to have. I wrote down this song's data so that no 2 notes on the saxophone will ever need to be played at the same time. For this reason, I created 1 path for the entire saxophone staff. Its preset D value had it off screen. It had to be something, but as long as it wasn't visible, that didn't matter. For each combination of pitch, head type, and shape type for different sections of the song, I created 1 set element. I added a comment attribute to each for my own convenience. Comment is not a supported attribute for SVG elements and is ignored by the computer, which makes it perfect for putting my own notes in. In the comment value, I would put the pitch and head and shape label I had written before. Each set had attribute named D, a 2 value identical to the D of the corresponding shape I had drawn in Inkscape, and fill equals freeze, which indicates the set command should remain active indefinitely until something else interrupts it. And then each set would have a begin attribute with anywhere between 1 and several hundred values. The begin attributes of each set element are why I did the previous steps, why I put all that stuff into the spreadsheet. In order to find every occurrence of a given pitch and head and shape, I just needed to sort the contents of the spreadsheet until all of them appeared together. I then copied all of the values in the time column, pasted them into a blank Notepad++ document so I could replace all of the line breaks with semicolons, and then pasted that beast as the begin value. It looks like hell, but it works. It does what I need it to do. The process for the percussion staff was different, but not too much so. There are 3 different types of percussion, any of which can occur simultaneously, so I had to create 3 different paths. Each one had its own set elements, each of which had its list of begin values. These were also distinct in that they did not have a fill attribute specified, so defaulted to fill equals reset. They had an extremely short duration, so that they would flicker on and then off and leave the shape invisible again. Among the Ceph was made differently. Among the Ceph looks like spinning, spiraling, the desperate flapping of wings. I honestly went back and forth for a very, very long time because I had too many ideas for how this song should look, but I eventually decided on 5 points arbitrarily assigned to notes in the song, whose height is determined by the pitch of the notes. Overtones would be indicated by ghosts of those points placed behind them. There are 5 Tier 1 paths in this SVG, one for each point, placed overlapping each other to appear as one continuous shape. Behind them are additional tiers of paths. They mainly contain animate elements as children, rather than sets, since they have to move fluidly like this. Each path's default D value has them laying flat, and each animate has a from value setting the point at a height corresponding to the note, and a to value equal to their starting D. If a note is displayed on point 1 and has head type 2, then 3 of point 1's paths need to be animated. However, if the next note on point 1 has head type 0, then only the tier 1 path should be animated. In order to keep the video more intelligible, more visually faithful to the music, I added set elements as children of all of the paths with comment false, which when triggered change the D value to its default instantly. False set elements are occasionally triggered on the tier 1 paths as well, at arbitrary moments I decided on for stylistic reasons. My process when making the augur was almost identical to the one for Among the Ceph. The most notable thing I want to bring up here is that none of the paths are animated. Instead, the animate elements present in this SVG are children of radial gradient elements, which are used to define the coloring of a path. Cool. So now I have completed my SVG. What now? Like I said, these are the only programs I use for the creation and editing of these files, and I don't know of any dedicated software that can turn them into video data. How are people supposed to watch this now that I've made it? I could record my screen during playback, but the problem with that is that it sucks. There is no way to full screen the SVG itself because despite everything it just is not a video, so I'd either have to make multiple recordings of part of the frame and stitch them together, or zoom out and crop the resulting recording to a weird non-standard resolution that would probably look wrong anyway. I also toyed around with the idea of changing my display settings so I could record at a larger resolution than my monitor could actually display, but I couldn't figure out how to do that. However, it turns out that OBS Studio has a source type called browser. It views web pages. Based on some rudimentary testing, I'm pretty sure it runs a Chromium-based client. You can feed a URL to it, and it will show it directly with none of the UI elements associated with regular, standalone web browsers. But just like a web browser, it can also view locally hosted web pages when given the link to a file on your own computer. And it can also view SVGs. It is a weird way to do things. It is not a way things are usually done. It feels very tantamount to taking a screenshot of something you've made in Photoshop, but it is in a way less of a kludge than that, and most importantly, it works. It gets me the thing I want. I input the SVG, and it outputs a full-res video, albeit with some leading and trailing junk. I put the video into my editing software, sync up the music to it, and that's what goes on YouTube. Thank you for watching.